Here are the notes for Chapter 5A. We are starting with Section 5.1, using our fundamental identities. And we're going to start off by talking about our Pythagorean identities. Now, because they're called Pythagorean identities, they're coming from the Pythagorean theorem. And so I've drawn a picture already of a unit circle where we've looked at one point on the unit circle, which is an x, y point. Now, if you remember, your x relates to your cosine of theta, and your y relates to sine of theta. But also, by looking at that right triangle, I know that x squared plus y squared equals 1. So using substitution, I can substitute the cosine of theta and the sine of theta into my Pythagorean theorem, and I end up with cosine squared theta plus sine squared theta equals 1. Now, you're more likely going to find this written in a reverse order of sine squared theta of cosine squared theta equals 1. Both of them are the same. It's just this second one is the more common way you're going to see it written. And it's pretty much the one you want to memorize, because it's going to be used a lot. Now, from that sine squared theta plus cosine squared theta equals 1, I can find my other trig identities. And so I'm going to go over here and I'm going to write it down again. Okay. And what I'm going to do is I'm going to just do a little bit of division. So first thing I want to do is I'm going to divide both sides of my equation by cosine squared theta. Okay, so if I do that to both sides and then simplify, I end up with sine squared theta over cosine squared theta. Well, that's tangent squared theta. Plus cosine squared over cosine squared is 1 equals 1 over cosine squared is secant squared. There's my second identity. And you'll find it on the top of your notes under important identities. And it just came from that first one. Now let's say I go back to that sine squared theta, and that plus cosine squared theta equals 1. Here we go. But this time, instead of dividing by cosine, I want to divide by sine squared. So I'm going to divide everything by sine squared theta. And simplify. So sine squared theta over sine squared theta, that's a 1, plus cosine squared theta over sine squared theta, that's cotangent squared theta, equals 1 over sine squared theta is cosecant squared theta. And that is our third Pythagorean identity. But again, all of them, both of the last two, come from that first one. So you really need to make sure you memorize that first one. And then you can find the others from that. Now, one other thing I want to just talk about is I'm going to go back to my original identity, and just to make you aware of a few things from it. So if I have sine squared theta plus cosine squared theta equal 1, what I want to be able to also look for is getting one of these by itself. So if I get sine squared theta by itself, by moving that cosine squared theta to the other side, I get sine squared theta equals 1 minus cosine squared theta. So if I ever see in the work that I'm going to be doing 1 minus cosine squared theta, I can put a sine squared there in its place. So this is another one that you kind of just want to watch for. And as well as if I got cosine squared by itself. These ones definitely show up a lot. And you kind of watch for them, because you're going to be working with a lot of substitution and simplifying and doing a little bit of algebra. And so whenever you can substitute one, like sine squared into for 1 minus cosine squared, it's probably going to make your life a little easier with this. Alright, so let's move on to our first simplifying. So these first couple of problems, we're just going to be simplifying. So let's go to the first one, number 1, which is 1 minus cosine theta times 1 plus cosine theta. And all we're going to do is we want to multiply them together. Now this first one, I'm going to walk you through the multiplying. So we're going to want to just multiply these two binomials, just like what we've been doing. So we're going to take 1 times 1 is 1. 1 times cosine is cosine of theta. Negative cosine theta times 1 is negative cosine theta. And negative cosine theta times a positive cosine theta is negative cosine squared theta. Notice where the squared goes. The square goes between the cosine and the theta. It's not after the theta. Now look at it and say, what can I do to simplify it? Well, I have a positive cosine and a negative cosine. Those are going to cancel. And I'm left with 1 minus cosine squared theta. And I have to look at it and say, can I do something else? Well, we just talked about this. 1 minus cosine squared theta simplifies to be sine squared theta. So we want to simplify these as far as we can. Alright, so number 1 is done. Let's go to number 2. So number 2 is 1 over sine squared theta minus 1 over tangent squared theta. We want to simplify that one. Personally, I'm not a big fan of the fractions, so let's get rid of our fractions. I know that 1 over sine is cosecant, so 1 over sine squared is going to be cosecant squared. So let's change that to cosecant squared. Theta minus 1 over tangent squared theta is going to simplify to be cotangent squared theta. Now remembering those identities that we had, we also have that cosecant squared theta equals 1 plus cotangent squared theta. So I'm going to just substitute that in for that cosecant. Now simplifying, my cotangents are going to go away, and I'm left with my answer of 1. Alright, so that's it for number 2. Let's move on to number 3. So number 3 is we're squaring sine x plus cosine x. So I want you to pause the video right now, and I want you to multiply it out, and let's see how you do. Okay, so hopefully you remembered that when you have that square there, that means you actually have two parentheses that are exactly the same, and you multiply it out, and you get sine squared x plus 2 sine x cosine x plus cosine squared x. And when you look at this, I have a sine squared x plus a cosine squared x. Both of them are positive. That's my Pythagorean identity. So those will substitute and just change to a 1. Plus 2 sine x cosine x. Now looking at that, I don't have another identity that's just sine x cosine x right now. So, because all my other identities involve squares, or they involve a fraction to try to change it to a tangent or cotangent. So we're done with this one. Okay, So let's move on to number 4. Number 4 is a little different than the others. Now we have an equal sign in there, and we're now going to be proving or verifying these identities. In order to prove or verify, we need to remember a couple of things. First one, only work one side. Okay. If you work on both sides, it is going to be completely wrong. So you pick a side and you stick with it. Generally, you want to pick the side that looks more complicated, because then you can simplify it. But that's not always the case. So sometimes it's a trial and error. Okay? So let's look at the one we have here. And I have sine x times cosine x over 1 minus cosine squared x equals cotangent x. So the left side looks way more complicated. So I'm going to start there and see what happens. Now when I look at it, I'm like, I have a 1 minus cosine squared x. Well, from what we talked about earlier, I know that's sine squared x. So I'm going to put in sine squared x. Equals cotangent x. You need to bring down both sides. You need to bring down that cotangent x with each step that you're doing. You're showing that both sides are equal. You can't just do one side. You got to bring them both down. Now with that, I know now I can cross off one of these signs. The one on the top and one of the ones on the bottom. And that leaves me with cosine x over sine x, which is my cotangent x. And both sides now match. So there's your first proof. You just verified that those two sides are equal. Okay, let's move on to number 5. Okay, so I have a pair of binomials on the left side equals tangent of theta. Probably the best way to go is multiply those binomials out. So pause your video and why don't you multiply them out. Okay, so once you multiplied it out, you've got cosecant theta times secant theta plus cosecant theta minus cotangent theta secant theta minus cotangent theta equals tangent. Kind of looks like a mess. I have no squares, so I can't use any of my regular identities yet. But what if I changed everything to sine and cosine? And that is one of the options that you have, is you can change things to sine and cosine. If I change this, I can change the cosecant to 1 over sine theta times 1 over cosine theta plus 1 over sine theta minus cotangent is cosine theta over sine theta times secant's 1 over cosine minus cosine theta over sine theta would equal tangent theta. So we can't touch that right side, so don't try to change it to a sine over cosine. Leave it alone. Now if I look here, in the middle, right here, I can kind of simplify that a little bit. I can cross off the sines, or the cosines. And that's going to leave me with a 1 over sine there. So now I have 1 over sine theta cosine theta. And I'm going to, later on you'll learn to kind of cut out a few steps, but right now I'm going to do every step over 1 over sine theta minus 1 over sine theta minus cosine theta over sine theta equals that tangent theta. Okay, my two middle fractions are going to subtract out. And so I'm going to be left with the 1 over sine theta cosine theta minus cosine theta over sine theta. So we want to get a common denominator. The common denominator is going to be sine theta cosine theta, so I'm just going to write that down. My first fraction already has that denominator, so my numerator doesn't change. Minus, I have to multiply the second fraction by cosine on the top and the bottom, and that gives me cosine squared. So now I have 1 minus cosine squared on top over sine theta cosine theta equals tangent theta. And again, there's that 1 minus cosine squared theta. So I can substitute sine squared theta over sine theta cosine theta equals tangent theta. Cross off to simplify, and that leaves me with sine over cosine, which is my tangent. Okay, there's number 5. Let's move on to number 6. Okay, so number 6, I have two parentheses, cosine theta over 1 plus sine theta plus 1 plus sine theta over cosine theta equals 2 secant theta. No squares, so there's no, and it's already in sine and cosine, so I can't change anything. So let's just add the two fractions together. So common denominator is going to be 1 plus sine theta cosine theta so my numerator now is going to be cosine squared theta plus 1 plus sine theta, the quantity squared, equals 2 secant theta. So let's multiply out our binomial. So pause the video and multiply it out, and let's see how you do. Okay, so should have ended up with cosine squared theta plus 1 plus 2 sine theta plus sine squared theta. Well, looking at this, I have a sine squared theta and a cosine squared theta. I know those are equal to 1. Plus the other one I have up there gives me now 2 plus 2 sine theta over my denominator and that's going to equal 2 secant theta. Okay. If I factor out a 2 in my numerator, I end up with 2 times 1 plus sine theta over 1 plus sine theta times the cosine of theta equals 2 secant theta. Cross off my 1 plus sines, thetas. And now I have 2 over cosine. Well, if I take the reciprocal of that, that gives me the 2 secant theta, which is what I was looking for. Okay, so this one was a little bit longer, but again, it's involving some multiplying and substituting and then simplifying. All right, last one for today. Sine to the 4th x minus cosine to the 4th x over sine squared x minus cosine squared x. Now, sine squared x minus cosine squared x is not our identity, so we cannot just substitute a 1 there. Well, if I remember, on the top, I have a difference of squares. I can break down sine to the fourth x as sine squared x and another sine squared x. So I'm going to just factor the numerator as a difference of squares. So sine squared x plus cosine squared x times sine squared x minus cosine squared x. And I wrote theta, I'm sorry about that. All over my denominator of sine squared x minus cosine squared x to equal 1. And if I look at that, I have the same factor on the top and the bottom, and so I'm going to just cross those off. And I'm left with sine squared x plus cosine squared x to equal 1, and I know that that identity is equal to 1, so 1 equals 1. Alright, so that is the end of the notes for section 5.1 using our fundamental identities. We will be continuing on with this topic throughout this unit. If you have any questions, make sure you come to class with them.